All right, so question 7, we're starting to bring together our topics. So net force, I mentioned before, doesn't have a particular formula. If we can find it, then typically we can do some stuff with it. But we have to stop and think in any given case what the net force is going to come from. So we have some person pushing with a certain amount of force. It's talking about friction, and friction is always going to work against you. So think about that just a tiny bit, and I think you can get there that the net force is going to be equal to the force from the one person, because we don't know who it is. You say A or P for person, whatever, um, is going to partially be wasted, right? Some of that force is going to go away because they're working against friction. Okay, so part of this is really easy, right? Because the force from the person, we already have that. That's F1 and that's right here. But we start kind of digging in and looking at stuff, we're going to notice a problem, right? Because the force of friction is not something we know. So we have to stop and think, all right, well, where does it come from? And can I use that information to maybe come up with that now, right? And so the force of friction has a definition. It comes from mu, the coefficient of friction, which is just some decimal number, and multiplied by net force. All right, so hey, we're doing good, right? Coefficient of kinetic friction, this one happens to be quite a bit lower. So I mentioned before that kinetic was usually a smaller number. It kind of didn't happen, but here we see it's a lot smaller than our other example. So that's great. We have, half our information again. So, here we got to dig in a little bit further and we have to figure out normal force. So if I can find normal force, then I have sort of a cascading or a snowball effect where everything is going to finally fall into place and it's all going to work. Okay, so what do I know about normal force? Where does it come from? Well, if I have the right information, then normal force is equal to the weight of an object as long as I've got it, sitting on the surface or moving along the surface. Uh, well, unfortunately, I don't have that information. So I have to see, all right, well, look, what do I have and how can I use it to get somewhere? So I have mass in kilograms. And remember, all right, well, where does weight come from? Well, that's mass times gravity, which arguably is our fourth formula, third and a half formula. I don't know how you want to call that. Um, it seems like a lot. It seems like we're digging a deeper and deeper hole. But as I mentioned, as soon as we find an answer to something, all the rest of it's basically going to work, right? So I can find the answer right here. Finally, we're going to make progress. And that's going to be our way to get in and get the rest of it done. All right. So we have mass given to us. Gravity, we need to understand, is going to be hopefully the same number always. It'd be a very strange question and very obvious if gravity ever needs to be a different number. All right, so multiplying these together, 3038 newtons of normal force. Finally, we know something. We have an actual number answer for for our information here. So now I can take this. Now that I've learned something, let me see what else I can do with it. So normal force, that was the thing I needed to know in this red formula in the middle that was holding me back. So let me see what I can do here. Now that I've learned something, maybe I can learn something new. Maybe I can continue my progress. All right, so mu, that coefficient, 0.15. So in this case, basically 15% of your normal force turns into friction. That normal force, we didn't know. We had to go on a bit of a journey to get there, but we do have it now. And so finally we can connect all the dots and we can get that the force of our friction is 455.7 newtons, which is great news because now, back to the original problem, our first issue that caused the hiccup, I know the force from the person and now I know the force from friction working against that person. And here we are. All right, so now that I have all of my information, I can plug in, work a very simple question to finish up. So, a bit of preparation here. But once we got everything lined up, you'll see, very quick, two numbers in a calculator. We want to find the difference here. You can think of friction as being like taxes, right? So you got a certain amount of money on your paycheck, paid whatever in taxes, number comes down, and you only get to use what's left over. So same thing here. We had a certain number of newtons of force. Some of it gets wasted because of friction. We're only able to use what's left over.